Yes, we do. Yeah, so this is really short though. Okay, so here's the last part. Okay, and this is, being as we can't be in the lab, we might as well get this done so you get more lab time when we have it. So we just get 2 more patterns. Now look at these patterns. There are 6, easy to remember, there are 6 possible permutations of the letters A and S here. You have 3, with 3 of each. We have these are the ones that work, so we'll write them in green. Right, the ones that work so far are SSS, SAS. We get 2 more. We get angle, side, angle, and angle, angle, side. Now we'll write in red the 2 that don't work, right? There are 2. One of them that doesn't work, if you think about it, the angle, angle, angle one can't work. Just because 3 angles of one triangle are congruent to 3 angles of another triangle does not mean they're congruent. They could be totally different sizes. For example, look at these 2. What if I have this triangle right here and that triangle right there? I could still have those 2 angles being the same, being congruent, and those 2 angles being congruent, and those 2 angles being congruent, right? They just have to add up to 180. But the triangles could be much different sizes. They might be similar, as we'll talk about later. If they're the same shape but different sizes, we call them similar. But those are obviously not congruent, are they? So one of them that does not work is angle, angle, angle. Now the other one would be, I'll write it in a kind of a more polite way, SSA. But you can say these in any order you want to, really. So if that one we could choose a different permutation that might not be quite as appropriate, right? So that's easy to remember also. The one that you could write that you probably would, that maybe your mom and dad wouldn't want you writing is this guy right here. That's the other one that doesn't work, right? So the 4 that do work we have, the 2 that don't work, it's easier just to remember those. And all the other ones work. All the other ones work. Those are the 2 that don't work, every other one does. Okay? So let's just quickly, and really all I'm doing now is just plugging in, these other 2. And that's it. Okay? Same exact kinds of problems we just looked at a second ago. So here's an example. The angle, side, angle congruence postulate just says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then those triangles have to be congruent. So it would look like this. If I've got, say, angle C congruent to angle D, angle A congruent to angle F, and the side, when I say included side, see what that means? That's the side that's a part of both of those angles, right? And once again, I think it helps if you imagine an ant walking around the outside of this triangle, he's going to hit an angle, and then he's going to hit that side, then he's going to hit this angle, and then he's going to hit this side. See what I'm saying? If he hits these features in this order, if he goes from an angle to a side to another angle, that's angle, side, angle. Okay? So here's the picture that goes with that one. The other one we get is angle, angle, side. Okay, now notice, as the ant walks around, this time it's a non-included side. As the ant walks around the triangle, he's going to go from angle C, there's nothing going on with this side, is there? He's going to skip that side, go up to angle A, round the bend, and hit the congruent side. So the order in which he hits those angles and sides is 1 angle, 2 angle, side. Angle, angle, side.
The first was ASA?
Yes. Yep. Angle, side, angle. So now we've got side, 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 angle, side, right? So 2 sides in the included angle. Angle, side, angle. 2 angles and the included side. And then finally the last one is 2 angles and a non-included side. If 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of a second triangle, then the triangles are congruent. Now this one is the trickiest by far, because what if we had something like this? What if instead of this side being congruent, it was this side right here? You see that those are not corresponding sides? See what I'm getting at? Okay, like I'll show you something. Is that about the right color? So what if I just block him out? And what if mark were there instead, well, that would not tell you those triangles are congruent. It's possible they might be, but more than likely they're not. You see, look, I've got two angles and an included side, and a non-included side, but this time the non-included side is next to the single arc angle, right? This one down here, this non-included side is adjacent to the double arc angle, right? So they're not in the same spots, and so that would not work, okay? But that does, right? In this case, I've got two angles and the side next to the double arc congruent side, and so that does work. You have to be real careful with this one. It's easy to mess this one up. So how could we, let's see, it's in right? Yeah, here, I'm gonna go. So how could we prove this then? Okay, if we've got these two triangles, is it possible to prove the triangles are congruent? All I've got are two parts. I need a third. What's the real obvious one I can get out of this? What do you think, Wallace? Say it again. EGF, good. And okay, good. Yeah, the vertical angles, good. So I've got these other angles here that I can add. I've got those two, right? Now, does that work? Take a close look at that and tell me, does that fit one of our patterns? It fits angle, angle, side, doesn't it? Because I've got two angles and a non-included side of the left triangle are congruent to two angles and the corresponding non-included side of the other triangle, right? It's the side that's next to only the single loop congruence mark, right? The single arc congruence mark is the side that's congruent, so it works. And the ant hits him in the right order. Walking around this one, he goes from an angle to an angle to a side, angle to an angle to a side. Right? Okay, so it does work. Okay. What about this one? Is it possible to prove those two triangles congruent? If that's all we're given. Is there anything we know there that we can add? Any other congruences we can add easily? Yeah, good. We always want to look for a shared side, don't we? Right? So we know that both the left triangle and the right triangle share side NP, so that's a freebie, right? But we don't know anything else about it. We don't know that any of those sides are parallel, right? We don't know much else. Can we do it? But we don't know these other sides, do we? We don't know that MN is congruent to PQ. And there's no way for us to show that in this case because we don't know there's nothing helping us out. Say it again. If that would be true, if these two lines were parallel, right? If parallel lines are being cut by a transversal, but it doesn't tell us that. There are no marks on the drawing. You see what I'm saying? We don't have these nice little parallel arrows up here to show us on the drawing that they're parallel, and nothing tells us that over here in the writing either, right? So in this case, we simply can't do it. There's not enough information. We only have two pieces, and we need to have three that fit one of those patterns. So this one fails. Doesn't work. Okay, not enough information. What about this guy? This time we do know some stuff. This time we know that UZ is parallel to WX, so let's write that in. So I know this is true, and I know that UW is parallel to ZX. Okay. So does that help? Now it might help for us to maybe extend these a little bit, right? So I've got, say, there's a set of parallel lines, a pair of parallel lines. Right, and doesn't this look like a transversal? Does that help us? what angles congruences does that give us? Yeah, 1 and 4, doesn't it? Right? That tells us that alternate interior angles, so 1 and 4, alternate interior angles, right? Tells us that 1 and 4 are congruent. Whoops. Okay? By alternate interior angles, right? What else? Yeah, 3 and 2. Now I've got to move things around a little bit. To get 3 and 2, I have to focus on the other parallel lines, don't I? Right? To get 3 and 2, I've got to think of these lines right here as being parallel. Right? And there's my transversal. And so if these parallel lines are cut by this transversal, then 3 and 2 are the alternate interior angles, aren't they? Right? But I get it. So if I have these guys congruent and those guys congruent, is that enough? That's 2 things. Need 1 more. What could it be? Well, actually, that's true. By the third angle theorem, I could even show the other angles are congruent. That doesn't help me so much because we don't have an angle-angle-angle, do we? There's no A congruence postulate relationship in triangles. Is there something else up there I could get? Say it again. Yeah, they share a side, don't they? Good. So that looks pretty messy. So we have this, right? We know that those guys are congruent and those guys are congruent. And there we have it. WZ is congruent to itself, a reflexive property, right? Congruence. So now I've got it. I've got angle, side, angle of the left triangle, left top triangle, is congruent to angle, side, angle of the bottom right triangle. And that's an easy one, right? We know we don't have to be careful about that one at all. If 2 angles in the included side of one triangle are congruent to 2 angles in an included side of another triangle, then they're definitely congruent by ASA, right? You got it. Okay. I think this is the last one. So how could we do? Okay, what if we know that we know BD is congruent to BC, and we know that AD is parallel to CE. Okay, so ABD, we got some vertical angles. That's an easy one, right? We know those 2 are vertical angles, so they're congruent. That's 2 pieces. We need 1 more. Yeah, look, I've got 2 parallel lines cut by a transversal. Now, which one do I want to choose here? I got some choices, don't I? I could set these. This could be my transversal, and I could get angle A and angle E. But which one is easier to apply? Which relationship? Angle, angle, side, or angle, side, angle? Angle, side, angle. So let's pick that one. Let's let this one be the transversal. And so there are my alternate interiors, and I got it. Right? Angle, side, angle. Okay. Make sense? Okay, so you're going to actually have to do some of these really short, and they're not long. I mean, they're really, really short proofs. You're going to have to do some of those where I give you, most likely I'll give you 2 parts of a triangle relationship, 2 congruences, or maybe 1 in some cases. You got to come up with